You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your IT fundamentals certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. In this episode, we'll compare the most common types of local, non-volatile storage hard disk drives, solid-state drives, NVMe drives, and USB flash drives. These devices all retain data even after power is removed, but they differ in speed, design, durability, and use cases. Understanding how they compare helps IT professionals make smarter upgrade decisions, troubleshoot storage-related issues, and provide better recommendations for system design and repair. This episode builds on the storage concepts from our previous discussions, adding deeper detail about how each type fits into real-world IT scenarios. This content is directly tied to Domain 2 of the ITF Plus exam, where you'll be asked to identify, compare, and evaluate different storage technologies. Exam questions may ask about the best storage type for a given scenario, the differences between SATA and NVMe, or the suitability of a flash drive for a certain use. Understanding the key traits of each type of storage is essential for success on these questions and in everyday IT support situations. Let's start with hard disk drives, or HDDs. These are traditional mechanical storage devices that use spinning platters and a moving read/write head to store data magnetically. They've been a standard in desktops and laptops for decades, offering large amounts of space at an affordable price. Their reliance on physical components means they are slower and more fragile than newer storage types, but they continue to serve useful roles in many systems. The key strengths of HDDs are capacity and cost. You can find HDDs with 1, 2, or even up to 16 terabytes of space at a fraction of the cost per gigabyte compared to SSDs. This makes them ideal for archiving data, creating backups, or storing large media collections. However, because they rely on moving parts, they are more prone to mechanical failure and are less suited to environments with vibration or frequent movement. Solid-state drives, or SSDs, are the modern alternative to HDDs. Unlike HDDs, SSDs use flash memory to store data electronically. There are no moving parts, which makes SSDs more durable and energy efficient. They offer much faster read and write speeds, enabling quick boot times, fast application launches, and smoother system performance. Most new laptops and desktops now include SSDs as primary storage. The benefits of SSDs over HDDs are clear. Systems boot in seconds rather than minutes. Applications open quickly, and files load with minimal delay. SSDs are quieter because they produce no mechanical noise and consume less power, which extends battery life in laptops. They are also less susceptible to shock damage, making them better suited for portable and mobile devices. Non-volatile memory express, or NVMe, is a protocol designed specifically for high-speed SSDs that connect via PCI Express, or PCIe. While SATA SSDs are limited by older interface speeds, NVMe SSDs bypass those bottlenecks by using direct communication lanes to the CPU. This results in significantly higher data transfer rates, reduced latency, and better performance in demanding tasks like large file transfers and simultaneous application execution. Comparing NVMe and SATA-based SSDs shows how far solid-state technology has evolved. While both use flash memory, NVMe drives are up to 6 or 7 times faster in real-world tests. SATA SSDs are still a vast improvement over HDDs but are being phased out in high-performance systems. NVMe is ideal for power users, gamers, video editors, and enterprise environments where speed is critical. NVMe drives come in different form factors. The most common are M.2 modules that look like slim sticks of RAM and mount directly to the motherboard, and PCIe add-in cards that slot into desktop towers. These form factors save space and improve airflow. However, not all motherboards support NVMe, so compatibility must be checked. When upgrading, it's important to ensure the system includes an M.2 or compatible PCIe slot. USB flash drives are a form of solid-state storage designed for portability and convenience. They use flash memory just like SSDs but are accessed through a USB port. Flash drives are plug-and-play and widely compatible across systems. They are commonly used for transferring files between machines, backing up important documents, or creating bootable installers for operating systems. Despite their portability, flash drives have limitations. They are generally slower than SSDs, especially when using older USB 2.0 standards. Their small size also makes them easier to misplace. Most flash drives are not built for heavy read/write cycles, and their lifespan is shorter under frequent use. As a result, they are best used for short-term file storage and transfer not as a primary drive or for high-performance tasks. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Let's compare the typical storage capacities available for each device type. Hard disk drives HDDs commonly range from 1 to 16 terabytes, offering vast storage at low cost. Solid-state drives, SSDs, are typically available in sizes from 256 gigabytes to 4 terabytes, striking a balance between speed and capacity. USB flash drives vary widely, usually ranging from 8 gigabytes to 512 gigabytes. NVMe drives share similar capacities with SSDs but tend to be more expensive due to their high speed. In terms of speed, NVMe drives are the fastest, followed by SATA-based SSDs, with HDDs trailing far behind. NVMe drives can reach read speeds of over 3,000 megabytes per second, while SATA SSDs typically max out around 500 to 600 megabytes per second. HDDs, in contrast, often range between 80 and 160 megabytes per second. Flash drives vary depending on their USB version. USB 3.2 flash drives may approach SSD speeds, but older USB 2.0 models are much slower. These speed differences directly impact boot times, file transfers, and system responsiveness. HDDs remain valuable in specific use cases, especially where cost-effective large storage is needed. For example, they are ideal for media libraries, archival backups, and network-attached storage NAS systems. In desktop towers with ample space and minimal mobility needs, HDDs continue to provide solid value. However, their susceptibility to mechanical failure and slower speeds make them a poor choice for mobile or performance-sensitive roles. SSDs are best used as the primary storage device for operating systems and frequently accessed applications. Their speed allows the system to start quickly and applications to respond instantly. SSDs are common in laptops and modern desktops, where performance and reliability are crucial. Their low power consumption makes them especially effective in portable systems, helping to extend battery life while delivering consistent performance under load. NVMe drives are well suited for high-performance computing environments. Gaming rigs, video editing workstations, scientific simulations, and database servers all benefit from NVMe's high throughput and low latency. NVMe drives also reduce loading times in large applications and make multitasking feel seamless. While more expensive, they represent the cutting edge of personal and enterprise storage performance. Flash drives serve a different set of use cases. Their portability and plug-and-play nature make them perfect for transferring files, creating bootable installers, or temporarily backing up critical documents. They're often used by technicians to carry diagnostic tools, by students for project files, or by IT departments for imaging and deployment tasks. However, due to limited write cycles and lower speed, flash drives should not be used for long-term storage or daily high-frequency use. Storage reliability varies depending on the device type and how it's used. SSDs have no moving parts and are more resistant to physical shock, but they have limited write cycles, meaning each memory cell can only be written to a certain number of times. HDDs can store data for many years but are more vulnerable to vibration and mechanical failure. Flash drives degrade quickly when used intensively. For mission-critical storage, proper backups and redundancy strategies are always recommended. Installing these storage devices also differs by type. HDDs and SATA SSDs typically use standard 2.5 or 3.5-inch drive bays and connect to the motherboard via SATA data and power cables. NVMe drives are inserted into M.2 slots or connected via PCIe cards and require motherboard compatibility. Flash drives require no internal installation. They simply plug into an available USB port. Understanding these physical installation requirements helps technicians perform upgrades or replacements efficiently and without damage. Exam questions may ask you to compare performance between storage types or match a device to a use case. You might be asked to choose between an HDD and an SSD for a student laptop, or to identify an NVMe drive in a scenario involving large video files. You may also encounter questions asking which form factor or interface a drive uses. Reviewing these comparisons ensures you can answer accurately and with confidence. Real-world IT scenarios regularly involve selecting and supporting the correct storage device. From building custom systems to diagnosing performance issues, your ability to understand these differences will make you a more capable and trusted technician. Explaining why one user might need an SSD while another benefits from a large-capacity HDD allows you to tailor recommendations based on the user's needs, budget, and workload. Storage selection also impacts long-term system management. Choosing the wrong type may lead to slow boot times, frequent maintenance, or data loss. By understanding the strengths and weaknesses of each option, you can create systems that meet user expectations and reduce the risk of support calls. Knowledge of storage performance and capacity also supports better purchasing decisions and avoids wasteful upgrades. To summarize, hard disk drives, solid-state drives, NVMe drives, and USB flash drives each serve distinct purposes in computing. HDDs offer affordable bulk storage, SSDs deliver reliable speed for everyday use, NVMe drives bring high-end performance for demanding tasks, and flash drives provide portable storage for flexible use. Understanding these differences equips you to handle hardware selection, user support, and troubleshooting tasks effectively, and prepares you for ITF Plus exam questions with clarity and confidence. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.